Good afternoon or good morning, good evening, wherever you are. This is session 1AJ. It's in the CICS track and it's going to be the CICS Java update, but we do feature a special guest appearance of their very own CICS Java experience. So we have Rob Stroud, who will be speaking nearer the end. The main speaker today is Phil Wakelin from the Hursley Lab down in Hampshire, the home of CICS. So Phil, I'll hand over to you now.
Okay, thanks very much, Kit. Thanks very much, Nick. Let me just start by introducing myself. I work in CICS development, and I work with a large number of customers adopting Java in CICS. We've got some great customers using Java in CICS, and this is going to be an update about new function in 5.6, and also a brief look at 5.5. So let's just start with CICS as a mixed language application server. So with the introduction of Java EE8 and Node.js, we took the liberty, if you excuse the pun, of rebranding CICS as a mixed language application server in version 5.4. And this is a big shift as it shows a modernizing approach going forward. And in 5.5, we strengthen that position by building on our Node.js, Java EE support with Jakarta, and also with Spring Boot. And I'm going to go through all this functionality in a little bit more detail in the next few slides. If you do have any questions, feel free to ask them in the chat, and Nick hopefully will be able to call out your questions as we go. I will allow about 5 minutes at the end for questions before handing over to Rob, who's going to talk a bit about some of the experience at NatWest. So just to summarize the journey with CICS Java support, the Liberty support in CICS started in version 5.1, although we had Java in CICS before then, and that was with our basic servlet JSP, a web container in CICS, and our Explorer SDK with RESTful, JAX-RS RESTful services. We were built on that with 5.2 and 5.3. 5.3, we had Java EE6 web profile, and then in 5.4 and in with CD, so current continuous delivery APARs, and we did a lot of new function in 5.4, which is listed here with Java EE7. And the whole standard mode, full platform, ZOS Connect, Java Batch, Linked Liberty, MQ, and so on. I won't go into detail talking about those. That's a little bit too far in the past. I will talk about 5.5 a bit. And in 5.5, we had also quite a lot of function with Wait for Angel, multiple Liberty, secure servers, linked Liberty, sync point support. So a lot of hardening features and so on in 5.5, which we'll go through. And then in 5.6, we really improved our development experience with JCICS on Maven Central and the bundle deploy endpoint and tooling and the JCICS X API. Now, I'm not going to talk about developer experience. We've got another talk from Stu Francis about the developer experience, and I'd recommend that. So I'm not going to talk about those first three things. I will talk about our SBI enhancements, pause and resume, Spring Boot, Jakarta EE, and private storage monitoring, and a few other things. So let's start with 5.6 and work backwards. So in 5.6, I'm going to talk about Java EE8 and Jakarta EE. And Spring Boot, which are two big frameworks that we support and very popular, as well as some systems management items such as the bundle status enablement, endpoint pause resume in the admin center, and their private storage monitoring. So this slide talks about the evolution of Java EE. And Java EE has a long history in Liberty. And we've supported these specifications since Java EE6, as I mentioned. So Java EE7 was the first fully supported Java EE runtime in Liberty in Liberty 8.5.5.6, and that was supported in the 5.4 timeframe. Java EE8 is a set of evolutionary extensions to Java EE, and this has now actually evolved into Jakarta EE. Now, Jakarta EE is a community-driven open source model with more frequent releases than Java EE, so it's taken ownership of Java EE, enabling it to address more quickly the needs of modern applications. However, it's worth pointing out that the Jakarta EE8 full platform and the Java EE8 are technically equivalent. So this was a naming change, and a sort of transition of power between a Java EE and Jakarta EE8. And then as we get to Jakarta EE9, there'll be more evolutions coming along. So hopefully you've got that all straight. I don't think there'll be any questions in the quiz about this. You'll be glad to know. So what do we support in 5.6 regarding Java EE8, Jakarta EE8? So we support and supply the Liberty convenience feature, which is listed here, Java EE80, and that's like a super feature. Or you can deploy individual features for each specification. So Servlet 4.0 is probably the key feature in Java EE8, and which supplies support for HTTP 2.0. So that's the first support of HTTP 2.0 in CICS. There's the Java EE Security API, JSR 375, which is a portable standardized security model enabling you to build your security support directly into your web applications and move away from the deployment descriptors. And there's new versions of the regular features like beam validation, CDI, JAX-RS, JPA, and so on. And there's JSON B, which is a standard binding layer for JSON, converting Java objects to and from JSON. A couple of notes worth noting. Liberty with Java EE8 does not support OSGI applications deployed in an EBA. So they're called WABs in an EBA. So in Java EE8, you need to set the following property, which is a system property, which says IBM CICS Jvm Server WP WAB false. So that means we don't enable the WAB support in CICS, and that would enable you to move to Java EE8. We still support OSGI applications in OSGI Jvm servers. This is only a Liberty statement. For those of you who are gurus on Java EE8, you may notice there's no mention of JDBC 4.3. That isn't yet supported because it's dependent on Java 11, which is not yet available on ZOS and not yet supported. So moving on to Spring Boot, and Spring Boot is the new kid on the block when it comes to frameworks. And Spring was designed to simplify Java Enterprise Edition, really. It's centered around plain old Java objects known as POJOs and dependency injections, so using annotations to create the functionality you need. And it now encompasses just about most aspects of Java EE development. And Spring Boot builds on Spring Framework by adding components to avoid complex configuration, reduces development time, provides simpler startup experience. Now, we support Spring Boot and we support most functions in 5.3 onwards, and we have a rich set of samples and blogs to help you get moving, provide a quick leg up, quick start in CICS. So there's three different ways, principal ways of using Spring Boot in Liberty in CICS. The golden path, the most popular way, is probably Spring Boot applications built as a WAR, as a web archive. They're supported in 5.3 onwards, and these web archives are like regular web archives. We support full Liberty and CICS integration. That means you get CICS transactions, security, JKICS, and the full Java EE features available, and they can be deployed in a CICS bundle. You don't need to use the Spring Boot feature. The Spring Boot feature is for supporting jar applications, which are supported in 5.6 and 5.5 with the APAR listed. And these are Spring apps that can be deployed into CICS via Liberty mechanisms. However, most customers seem to be choosing to use WARs. You can only have one jar application deployed. So the WAR deployment model seems to be the most popular deployment model. The alternative is also to use the link model. Of course, in CICS, we have our exec CICS link model, and you can use the link to Liberty to link to a Spring Boot application from your COBOL application or any other language. The target Java method must be annotated with the @CICS program annotation, which is a part of the JCICS API, and it must use channels and containers. And that's again supported in 5.6 and 5.5 with the correct service. It's very important you have that correct service in both the runtime and also in the development environment, because the CICS annotation processor needs additional support to support linked Spring Boot. Okay, so that's everything about Spring Boot. So the next thing we did in 5.6 was to make our bundle status and config file polling more robust. So the CICS bundle status is now wired to the Liberty application status. So what does that mean? So this means that the CICS bundle, which is the CICS resource, which is used to deploy Java applications, and if that contains a web application bundle part, the status of the bundle is hardwired directly to the status of the Liberty application, so remains in enabling state until applications are started in Liberty. So this provides a robust lifecycle where the status of the CICS bundle can be used to ascertain the status of the web application, so you can build more robust application deployments. It's designed to allow you to use system policy rules based on the bundle status for automation. You can automate off the back of this. It also facilitates the use of the Liberty Admin Center, which is a Liberty tool for management. And it also facilitates the use of the mbean config file updates. You may ask, what's that? So this means that the Liberty management beans can be used to trigger the install of web applications. So if you change your config to update trigger mbean as shown, that means instead of continually polling the server XML every 5 seconds, then that is triggered by the mbean being triggered. So this is a more efficient means for updates. So if you move to this mechanism, it will reduce the ZFS IO usage, so reduce the EXCP counts in your region, because you haven't got that continual polling looking for updates and updates on the server XML and the installed apps XML files. So this slide shows you the Liberty Admin Center. So you can see it's a graphical web-based interface to view the status of the JVM and applications. So you can look at JVM threads and applications, a number of applications and status and so on. So very simple to use with a simple feature, the Admin Center, and then a simple landing page. I also mentioned the Liberty pause and resume function. So Liberty pause and resume provides the ability for web applications in Liberty to be paused, so stopped and taken offline without terminating the JVM. So that's very useful because this is much faster than terminating the JVM and means that you're not destroying the JVM, destroying the JIT cache, and so on. And this pausing also takes down the listening endpoints. So the HTTP listener and MDB listeners. This pausing can be driven by the Liberty server script, which is a USS management script. It can be driven by an mbean. An mbean is a Java bean. It can be driven programmatically by Java code, and it can also be driven by a new CICS SPI, which drives the mbean. So exec CICS set JVM endpoint is a new CICS SPI in 5.6. So you can actually drive that command to pause Liberty. You can either pause specific endpoints or pause the entire server. So this is very useful for building in automation around the deployment of applications. So this is a common customer problem, and this slide summarizes the problem. So the problem is that if Liberty HTTP endpoints start before the web applications are ready, a web request can be made to CICS, to the Liberty listener in CICS, but it won't find the web application because it's still starting. So you get a 404, a context route not found, until the application gets round to starting. And that may take a second, or it may take many seconds. So solutions that customers have used for this have been, for instance, you can use the Jvm Health support in CICS, which was made available in 5.4. And you can set Jvm Health open and closed. And if you have a shared cluster environment, that can solve this problem by preventing new requests arriving at that endpoint when it's closed. Now we do have a new option. So number 2, you can use exec CICS set JVM endpoint to pause the JVM endpoint. And you could drive that, for instance, from a CICS systems policy. And we've got a whole blog on how to do that. And the blog is on our IBM Z community. And that's avoiding HTTP outages by managing Liberty endpoints. There's also some additional functionality provided by Liberty. And this applies when you're not using CICS bundles, but you're deploying your web applications directly in Liberty using application elements, which is a choice that's open to customers. And in this instance, you can just set a start timeout directly on the application manager element. And Liberty provided some function through this issue 7709. So all Liberty development is done through the Open Liberty project now. And there are Git issues raised, and the Git issue there 7709 describes the function. And this function defers opening the listener until all the applications deployed in the server XML have been started. Now, in the CICS model, applications are injected into the server XML when they're configured. So this doesn't apply to the CICS bundle model, but it does apply if you just use application elements. Also, there's another bit of function that came out in FixPack 20006 with issue 7331, and that means you can order the applications via their application elements to say application A starts before application B. So another very useful bit of functionality there. So in 5.6, we also supported Liberty product extensions. So what's a product extension, and why do I want to extend the product? Well, in Liberty, a product extension is a collection of one or more user features. So it's a way of packaging user features. And a lot of customers, well, a few customers have used user features to extend the Liberty runtime to provide special customized monitoring or management function. So this supporting CICS is just a way of packaging those user features. And you can't use Liberty product extensions very well in CICS because the WP installer is not writable. So instead, we've got this new Liberty new CICS environment variable Liberty product extensions option. And you can set the Liberty product extensions option as shown. And that, for instance, would set Liberty product extensions to my extension semicolon/u/dir. So the /u/dir would be the location, and the name of your product extension would be my extension. So also in 5.6, we had the CICS Jvm Server Sbi Enhancements. So these Sbi enhancements are designed to make it simple to capture diagnostics. So it's a serviceability aid. So our service team may well ask you to supply some diagnostics from your CICS Java runtime. And that could include capturing Java dumps, often Java cores, or heaps or snap dumps, a Liberty dump, these dumps can be very easily taken using the SPI and also by CMT, and then they can also be gathered up into a tar file. So you can actually use the gather diagnostics to capture all the relevant diagnostics, which includes all dumps and all messages and log files into a single tar file from ZFS, and this just gathers diagnostics in ZFS and packages them up into a tar file, and then you've just got one tar file that you can send to your to the service teams, which is really makes it really easy to gather diagnostics. So also in 5.6, we have some new function in CICS to monitor the MVS private area. So this is not anything directly related to Java, but it is of very significant interest to customers using Java in CICS. This slide tries to highlight that because it shows the layout of JVM storage in the CICS address space. So this is a 64-bit JVM, and we've got the three traditional areas: the 24-bit area, 31-bit area, and the 64-bit area. So we've got the 64-bit area above the bar, the 2 gig bar, and then we've got the 31-bit area below the bar, and the 24-bit area below the line. And each of those areas of storage contain important bits of MVS storage. Now, the JVM stores a lot of the 64-bit JVM stores its heap and a lot of its storage, its stack and its JIT caches above the bar, so in 64-bit. So it's not constrained except by the virtual size of the mem limit, the virtual storage limit. However, the 2 gig storage area can become constrained, particularly if you have multiple JVMs, because you have to share the RAM classes, the native libraries, and the JIT code cache and Java stack areas with whatever is used below the bar by CICS and everything else that is loaded into CICS. And so CICS will now monitor and do some management of the available private area. So on the left, we can see the CICS EDSA, which will be the CICS 31-bit DSA for managing a CICS allocated CICS managed storage. And then we have a certain amount of free private area, which is the area above the allocated storage up to the bottom of the extended private area. And that would be a few hundred meg in size typically in a CICS region. So how is this managed? So there's a set of feature toggles. Feature toggles are name value pairs in a ZFS file in the USS config directory, which can be set on a region basis. This is turned on through the feature toggles, as you can see. And we have a set of toggles which control both the frequency of storage calculations, which defaults to 60 seconds, and then the amount of 24 and 31-bit storage areas, which are essentially storage area cushions which CICS will monitor to make sure that amount of total and amount of contiguous storage is available before it starts warning you. In addition, once CICS goes into that storage area, we become short on storage on MVS storage. At the moment, the only thing that will affect is the open TCP allocations will start to wait with the MVS store state. So that means if you were attempting to allocate a new L8 or L9 TCP, you will be put into a wait state and the MVS store state. So this is the kind of messages you might see in your CICS region. So CICS might be CICS initialization. You'll get some messages about 24 and 31-bit storage, telling you how much unallocated storage we've got. So here, for instance, we've got about 4 meg of 24-bit, and we can see we've got about 1.2 gig of unallocated 31 bits. So we've got lots of space there. And then the system task will periodically monitor storage. Just going back, and we can see that that runs by default at 60 seconds. And it will tell us when the region goes into short on storage being when the allocated storage goes into the SOS buffer. So see the black dotted line is the SOS buffer, and once the allocated storage, so once the sum of the CICS, EDSA and all the other components goes up to the dotted line, we'll start issuing messages. The messages are reissued if the storage remaining significantly changes, and you can see we get those SM0149 and 150 telling you if it's short on storage or no longer short on storage. And so because these are all SM message numbers, you can use a system policy to automate from these messages, and the system policy could set the region WM health, for instance, open or close, to say the region is not healthy. So these will be very useful if using Java in CICS, particularly for monitoring 31-bit storage, which can be an area of contention for customers using Java in CICS. Okay, so let's have a look at 5.5. So what do we have in 5.5? So we had support for JWTs, which was first introduced in the 5.5 timeframe. We had to wait for Angel and some JVM profile includes and some simplification and the new JVM log. So let's have a look at these in a bit more detail. So Json Web Tokens, or JWTs. So JWTs are becoming a very popular means of providing enterprise-wide security. And Liberty in CICS provides a really good range of JWT support. Now, there is also native support for JWTs in CICS, Executives Verify token, but that is not designed for externally signed JWTs. That's really an MFA solution. So if you want to use externally signed JWTs, Liberty is currently the way to go. So let's step back. What is a JWT? A JWT is a cryptographically signed token in a JSON format that's used to securely transport information known as claims between two parties. So here we can see we've got a claim. It's encoded, base 64 encoded. If you break it down, you'd have a header, and that will tell us the algorithm for the signature algorithm. And then there'd be a payload with some claims in it, and we'd have and then a signature on it. So the interesting bit would be the payload. So here we have the issuer, the subject, the audience, expiry, and I think the issued at. So it has some timestamps which dictate when it expires. And then we have the issuer, and that will be IDG here. The subject, which is the most useful claim typically, and that's essentially the authenticated identity of the owner of this JWT. And then we have the audience, which is like the target audience. Now, you can have a wide variety of claims, but the subject is the claim that is most usually used, but other claims can be used. The Liberty provides a feature, the JWT feature, and that means you can programmatically parse, build and verify these in Java very simply using their provided APIs. We've got a set of samples showing you how to do that. You can use the Liberty support for RACF key rings and Java key stores to store the certificates, to verify the signatures. And this was supplied in 5.5, but is also available on 5.4 and 5.3 with the APAR listed. And this function could be used in a servlet or in the Liberty security modules, the TIE or the JASPIT security modules. Now I've got some slides just to show some real use cases of how customers are using JWTs in Liberty and CICS. So in this example, we have a JWT authentication mapping a JWT claims to a specific SAF user ID in RACF or top secret. I can't remember what they're using. So here we've got Windows, a system with RESTful clients, and they've got their own OAuth identity server, and that authenticates the user. That's outside of Z. And we just get a JWT flown into CICS Liberty in a HTTP header. So we get our JWT comes across the wire. So the TIE, which is the Trust Association Interceptor, and that's a security module in Liberty, has access to the HTTP headers and can parse the JWT. So that would first validate the JWT signature using the public key, which has been distributed and stored in a RACF key store. And if that validates the signature, then you know it was signed with a private key. And these claims can be trusted based on the trust you place in the public key and your RACF database. So in this instance, I think the customer extracts the client ID and the issuer claims, and then it performs some custom mapping the client ID and the issuer claims to a SAF user ID, and it does that using by building a hash map, and then Liberty can map that dynamically using a rack map to a user ID. So that's a fairly sophisticated bit of function. Then we end up with a user ID. So we then end up with a RACF user ID. The registry can then, the TIE can then validate that user ID exists in the registry. And there's a method there that's used to check that. And if that's all good, then it can just set the subject for the servlet as that SAF user ID. And that then becomes gets pushed onto the CICS task user ID by the Liberty security feature, and your CICS transaction runs under that user ID as its task user ID without requiring any password authentication. The user ID is asserted based on the processing in the TIE. So that's quite a neat little bit of security infrastructure. Another way of doing this is the OpenID Connect client feature. So OpenID Connect client is supported as a set of Liberty features that build on top of JWT and OAuth. Now, there are many different ways of using OAuth and OpenID Connect client, and this is a whole subject in itself. But this is a typical scenario shown here. And in this instance, again, we'd have our OAuth identity server outside of CICS. The distributed platform will probably use LDAP registry, and we'd flow in a JWT from that remote Java E application into CICS Liberty. And then the OIDC support in Liberty will then dynamically consume and extract a specific claim, by default the subject, and map that to a RACF user ID based on a rack map. You don't need to write any code. This is all done through configuration in Liberty. And we have a whole blog on this that's just been published on Z Community that's listed, entitled Using OpenID Connect with CICS Liberty, that describes how to do this in detail. So that's another easy way of using JWT in CICS. A third example is another customer that we dealt with, and this customer used JWT support in Liberty to provide a JWT provider and consumer service. So here, for instance, and what's described here is described also in our white paper with a set of sample code. So in this example on the screen, we have a COBOL program getQuote and a COBOL program getScore. And getQuote talks to getScore using CICS Web support. So getQuote can be driven by a 3270 terminal, a user, and that can then do a link to a Java program called build.jwt, which can build a JWT. So it's just a linkable service, and that obviously could be deployed anywhere in your CICSplex because the link could be dynamically routed to any Liberty JVM. So that builds a JWT, returns it, the COBOL program consumes it, flows it across in the HTTP header. The target of the link, the getScore, then parses their header, extracts the JWT. It then needs to verify that, and it can then link to another Java program called consume, or CNSM JWT, consume JWT, which can then verify the JWT, again using the Liberty JWT support and the SAF keying. So this is described in more detail in a white paper that is also again published. This white paper is actually on our GitHub, and this repo CICS Java Liberty Loans and Scoring is actually a repo for the source code, and that now contains the white paper as well as the sample code. Okay, so moving swiftly on, the Liberty Angel process is required to run in the same LPAR as CICS if you need any facilities that use authorized services. So any Liberty functions that are authorized. Principally, this would be any authentication or authorization based on SAF. Now, there was a restriction that you could only run one Liberty server in a CICS region if it used the Angel, and that was a restriction in Liberty itself. So we worked with the WebSphere team to address this limitation, and that was removed in 5.5. And we now have the ability to run multiple secure Liberty servers in a CICS region, which gives you the ability to have many more Jvm servers running in CICS, so you can have better application isolation or scalability without increasing the number of regions. In addition to this, we have the Wait for Liberty Angel. So we have a new system property, com IBM WS0S core Angel required true. So this is and that's actually a Liberty system property. When running CICS, the CICS Jvm server will actually use a special call to the Angel to validate the Angel is actually ready. If it's not ready, it'll wait and retry, and then it will issue a console command requesting go or cancel. So this enables integration with automation, and will obviously alert the operator if the Angel is not ready. And this gives more robust startup and IPL procedures, because if the Angel's not available, then things will fail at runtime. In addition, it's worth noting that you can also have a dedicated Angel based on this property, ZOS core Angel name, So you can have a dedicated angel for a group of regions or for CICS versus another product like to SMF. There's new support in 5.5 for JVM profile includes. So the JVM profile is a set of options configured in a text file that and this is used to configure the JVM server. So in 5.5, support was added for % includes, so you can include other profile contents to override configuration settings. This is particularly useful if you, for instance, you want to have unique ports, but you want to share configuration across cloned JVM servers or regions. You can also reference variables. So you can, here we define cloned as a variable. We set it to some symbols. So we're setting this path based on some existing symbols. And then you can actually reference the variable cloned as a symbol, the amper cloned semicolon. You can append to variables using the plus syntax. So it makes it much easier to include snippets and to override configuration components when you're configuring multiple regions or JVM servers with shared configuration. Also, in Liberty Server XML, you can pass variables into Server XML. So those variables we saw, they can be set in a JVM profile. Like here, we're setting this server include variable in the profile to a certain path, and then you can reference that using the env.serverinclude syntax in Server XML. So you can pass parameters into Server XML from a JVM profile. You can also inject bits of configuration into the Server XML by setting Liberty Include XML option in your profile, which will dynamically inject that XML into that region's, that server's Server XML. So lots of options there to make cloning and overriding easier. There's a new log that's also exposed for JVM servers. So log messages which were previously hidden in the trace file are now sent to a log. That log is by default the DFH JVM log that can also be redirected to JES. There's different levels of log: info, warning, error, and none. And that just contains messages which can help with the configuration and debugging of the JVM server. Okay, this is my last slide. So the last thing in 5.5 was removal of restrictions. So a couple of key restrictions that were removed were the removal of the Dpl subset restrictions for link to Liberty. The link to Liberty enables COBOL programs to link to Java in Liberty, and that's been widely adopted by customers. But one of the problems was that there was a Dpl subset restriction, meaning that you could only use the Dpl subset as if you were doing a Dpl. However, that's now been lifted, so the Java applications can now issue a sync point. They can use the JTA Java transaction architecture to create their own Java transactions, which will also use sync points. And also you can use a sync on return option on the Dpl call. So much more flexible sync pointing model. Also, there's the removal of the Sdfj Auth library. Previously, the Java load modules were in the Sdfj authorized library, so you had an extra authorized library for Java. Now all those authorized libraries are in the standard Sdfh auth library. That simplifies the setup of Java in CICS. Okay, so that's everything I've got so far. So thank you very much for your time. Please remember to submit your session feedback for this session. You can do it online. This session is 1AJ, and the QR code provided in the slides. And here's a few details about the GSE UK Conference 2020 charity. So back over to you, Rob.
Thank you very much, Phil. Very entertaining as usual. Thank you. I'd now like to invite our special guest speaker, Mr. Rob Stroud, to say a few words about a a personal experience, an experience that he has had using the CICS and Java capabilities that we've provided. So Rob, if you're there.
Yeah, hi Nick. I'm going to try and share my screen, everyone. So this is the first time we've tried to do this.
Phil, do you need to stop sharing?
I don't know, you tell me.
Oh, it's okay.
There we go. Okay. So we've had some very professional speakers, including Phil, and a very technical presentation. Phil's very up to date on the latest things with Java and what new buttons IBM are giving us to support it as part of the enterprise. I've been involved with Java as a CICS person, I think probably due to GSE, maybe when Andy Crasson, those you remember Andy, came along and told us that IBM were doing Java and CICS many, many years ago. And we were all kind of scratching our heads a little bit and going, well, does it work in CEDA? Can we CMT that? And trying to make head nor tail of it. And Java's matured along with CICS. IBM have invested a lot of time in it. And some of us have dipped our toes in, although mostly folks outside of the UK, and some run Java completely in CICS and no COBOL very successfully now. We haven't really played with Java before, and this is just a little experience that we've had at NatWest Group, formerly RBS, changed our name now to protect the innocent. And I wanted the guys who've done this POC to do a bit of a presentation, but timing is everything, and at the moment that's just not possible with the people that have been involved in this. I've been overviewing what's going on as a technical lead along with my colleagues at the bank. We've had some presentations on this. We've obviously been involved sort of day to day as we were doing some testing. So this is just like 5 foils. Not very technical, but just to give some experience of setting up Java CICS regions and also deploying a Spring Boot application, which is the latest sort of developer interface for deploying Java applications that IBM have sort of taken on board to put onto the platform. I know there are many others, but Spring Boot is the one that we're looking at. So I'm just going to try and take you through a little bit of an explanation. So this has all taken place this year. We've done it from scratch. We built Java regions in our sandpit, played around with the configuration, set up everything necessary to run Liberty. I'm not going to go into the details on that, but IBM have cookbooks on that, and it's pretty straightforward. We were using or trying to use dedicated CICS regions just for the Java stuff, just because it makes the configuration a little bit simpler. Those of you that know my site and setup, we've got CICS regions coming out of our ears, so it was really pretty straightforward for us to have separate Java regions to deploy this application. So the whole requirement came not from us as systems programmers, not from us just to have a bit of a play with this, but from a project and the business who were looking at doing microservices, looking at running Java on a pivotal Cloud Foundry platform. But they were still talking to the mainframe, DB2 data, potentially some CICS applications, but really looking at a whole platform, and also doing big numbers. We're a fairly big bank. Some of our requirements in terms of transactions, latency, is at the far end of the spectrum. So as soon as we start having applications looking at data on other platforms, or applications talking to applications on other platforms, we do expose ourselves to a little bit of latency concerns. Tuning's really important nowadays. If you can't get the latency right, then you're going to have threading issues. And if you need to support multiple threads, because things take a long time, you need a lot of kit. So one of the guys working on the project tabled at their end the idea of perhaps running Java in CICS, running some microservices in CICS closer to DB2, potentially closer in future to any of the mainframe applications they wanted to talk to help with just the feasibility of the whole thing and also cost. Because if things do take a long time, they tend to cost more if you want to run big numbers. So Spring Boot was chosen to deploy the application, and we knew that we could deploy Spring Boot in CICS. At the moment, we're CICS TS 5.4, so it's feasible, but obviously we don't have all the bells and whistles that Phil was explaining just now around 5.6 or indeed 5.5. So getting set up proved surprisingly easy. From a developer point of view, it's the same application. The Java developer for the things that we were doing in test bedding was the same on PCF and the same running in Java in CICS. There are some bits that Phil mentioned in his presentation, which I was told by the guys who've been deploying this. So yes, we had to use a WAR file, not a jar file. Phil gave some much better explanations than I'm capable of why you might want a WAR file. And we had to change the main application class and put an override in. And we were using Tomcat and the embedded web container had to be configured so that it could run slightly differently. But that was it. From a developer, from a coding experience, what classes people are using, it was pretty straightforward. We did a number of test scenarios on the platform once it was built. We played around with it in the sandpit, and then we moved it onto our dev environment. Our dev environment is quite busy. We're running upwards of 450 CICS regions on each LPAR, 6 LPARs. So at any one time, we've usually got between just under 3,000 and 2,500 CICS regions running. Probably a 10,000 MIP 6 LPAR box that's always busy. So it's not the ideal place, a dev box, to do benchmarking and performance testing. However, these are some of the results that we got out of our tests. So we're just running a CICS region, a simple transaction, SBCJ, but running different sets of code. On the left-hand of the side of the screen, we were doing gets, microservices, doing a call to DB2. We tested type 2 and type 4 JDBC drivers, and I think type 4 was slightly more successful. I can't tell you what these stats are, but you can see from the benchmarking and the response times that we were getting really good performances. You do have to warm up your CICS regions. I think that's something that's been mentioned on presentations in the past to get optimal performance. There's a bit of stuff that gets, I guess, cached in some way and needs to get installed in memory to get optimal performance out of this. But we were getting 500 transactions a second out of the get on the left-hand side of the screen, and on the right-hand side of the screen we're doing a post, which the worst performers were better than the get, so we were managing about 250 transactions per second. Again, this isn't some kind of vanilla IBM, clean benchmarking environment. It's a very busy test environment. We're getting quite a bit of offload onto the zips or zip eligible work. I couldn't comment to you right now how much we got onto our zips, because I'm just not really aware of the configuration we've got on the test box. Obviously, if some of the zip eligible work doesn't have a zip, it offloads onto MVSCPs. But the numbers straight up from like the first tests were remarkable, considering things that people have done in the past with Java, even people's experiences elsewhere and getting performance in production. So we were pretty blown away by this, blown away by the figures of sysprogs, and certainly blown away by the ease in which we could deploy the Spring Boot application, which kind of takes me to my last foil. What's good about this? It was really easy to do. All those things around Java development being quicker than COBOL, easy to deploy, not having to retrain staff. So we saved a fair bit of money. Mainframe zip seemed to be a lot better than the off-host solution. I think possibly because the off-host solution was a long way from the things that he wanted to talk to. So a loosely coupled solution against a closely coupled one that's busy and demanding on resource, which is what mainframes are good at. Running your old code, your new code together makes any kind of migration model or any movement of apps gradually from COBOL to Java much more flexible, much more easy, much less pinch points. Mentioned about performance, cloud, even though we're running it here in CICS, we could port the application to run anywhere. Pretty easy to do. So that again, from a development point of view, it just makes them so happy. And I think with the presentations that we've done internally, the architects and developers have also been a bit blown away. Some of the prejudices that they might have around a mainframe have been sort of taken down. Yeah, it's agile. It's certainly viable on CICS TS 5.4, and I'm sure that it would be a much better solution on CICS TS 5.5 with PTF supplied, or 5.6, or with whatever goodies the Vulkan release brings to us that comes out again in the future. So yeah, it's a real experience. I haven't got into the technical details kind of deliberately, but I'm quite happy to share things offline if anyone's particularly interested, or their architects are interested in just talking about this as general GSE user group sharing of information. I won't be giving away any crown jewels or secrets here. But yeah, it's been a real positive experience for us, and I wanted to share with the community. So apologies that it's not in depth and technical, but it is real and you can touch it, and I'm hoping that it bodes well for new projects in the future for us. That's it, Nick. I've finished.
Thanks very much, Rob. That was really interesting, and it was nice to hear from someone giving an independent view. We all like to think that when we create Java, CICS Java programs, any procedures, that it's all the greatest thing, but it's great to hear it from someone who's actually on the front line and having to use it. Phil, I invited you to unmute. Was there any last words you wanted to pass on? There are no questions in the chat.
No, just thanks to Rob. I know we've been working with NatWest, getting them up to speed, and they've been consuming a lot of the Spring Boot material that we've provided, and I think that's worked really well. So it's really good to hear about that. You know, I don't know if Rob can share anything about where they are on their sort of roadmap from sort of like POC through to you know, a development, test, and production. You know, have you got anything to say about that, Rob?
Yeah, I mean, at the moment we're kind of in the middle of COVID pandemic, and the project that was looking at this definitely had a stumbling point from a viability and feasibility point of view, and it's an awful lot of money being spent on this stuff. A lot of retraining of staff to Java, a new platform with Pivotal Cloud Foundry, and really just it's one of those practical things that you see once you get going with stuff, is that some of the architectural designs, although they look very pretty, in the real world where we're trying to deliver high volume, fast transactions for customers, possibly it's pretty much infeasible. The latency creates an awful lot of bandwidth, which you have to bite in for, and those costs are looking quite exorbitant. So there's definitely a cost version of this. We've presented to the senior architecture team. I presume they'll be having some kind of review over Christmas and making decisions on budgets and where they want to go with this. But we were looking at one particular area of microservices, which is unfeasible. The bigger stuff is, doubly or 10 times infeasible. And if we can buy into a pilot scheme on this on a particular microservice, then that makes it more deliverable. But high level decisions have to be made, Phil. That's the bottom line. But we did get very good feedback on the presentations last week. So we'll see.
Okay, thanks very much, Rob. Thank you all for joining. Please fill out the feedback forms. If you don't tell us what we do right or wrong, we may stop doing the good stuff, and we certainly won't be putting the bad stuff correct. So thank you all. I'm going to close the meeting imminently. Unless there's any last questions, please put them in the chat. But I've seen none. I've been monitoring it for the last hour or so. So thank you very much. Have a good evening, and probably see you again for the moon landing with Mark Nelson.